Hey everyone, I'm Ryna and welcome to GRE Fridays. Every Friday I'll be posting a video talking about some GRE topic, and today I'm talking about quantitative comparison questions, what they are, what you can expect, and I'll be walking through an example problem. Drop a comment if you have some specific topic from the GRE that you'd like me to cover, and check back here every Friday. I'll be posting new videos. Today I'm going to show you how to approach quantitative comparison questions on the GRE. Unlike typical multiple choice questions, this question type is not asking us to solve for an answer. Instead, we're given two quantities, quantity A, quantity B, and we're being asked to determine how these two quantities relate to each other. Let's take a look at this example question to see what the format of the quantitative comparison question is. There will generally be some kind of information at the top, so actually let me erase that. And for our current problem, the information at the top looks like this. We will be given the two quantities that we're going to compare. The answer choices for every quantitative comparison problem are always the same, so it's definitely a good idea to memorize these options. Here's the answers. We have A, which says that quantity A is greater. We have B, which says that quantity B is greater. C says the two quantities are equal. And then I'm going to squeeze D in here, which says that the relationship cannot be determined from the information given. So again, really important to just go ahead and memorize those. They're not even going to always be clear in front of you. You're going to just choose between A, B, C, and D. So in order to choose an option such as A, we need it to know for sure that A is always true, meaning A is always greater than B. In order to choose B, B must always be greater, and so on. So if we have a situation where A is sometimes greater and B is sometimes greater, then that's when we would choose option D. Let's take a moment to understand what this is actually telling us. So let's start with A squared B is less than 0. If we square a number, that number is going to be positive. So we can write that like this: A squared is greater than 0. And you can see that, for example, if you square -3, that's going to be positive 9. When we multiply now a positive number, A squared, times B, and our answer is less than 0, that tells us that we know A squared is positive, so B must be negative, so that we end up with a negative number as our answer. Great. Now we know B is negative. That's our big takeaway here. B is negative. All right, let's take a look at the A. B cubed is greater than 0. What we see here is we already know B is negative, so a cubed negative number is going to stay negative. For example, if we do -3 cubed, that's going to be -3 times -3 times -3, which equals -27. Great, so that means that A has to also be negative. in order for A times B cubed to be greater than 0. Awesome. So I'll just write up here our takeaway information from that stuff we got at the beginning. A is negative, B is negative. And if we remember, our quantities were A is A, and quantity B was B. Because of this, we just figured out both A and B are negative, so we don't actually know what the relationship is between A and B. So we must choose D. We don't have enough information to determine because we don't know which of these two values is more negative. Now, what if instead of this intro information, we're still comparing A and B, but instead we were told that A squared times B is greater than 0. And AB squared is less than 0. So this A squared times B tells us that B must be positive, because in order to get a positive number, we already talked about how A squared is positive. So a positive times a positive gets us a positive number. B must be positive. Now when we come down here, now that A is no longer squared, but we have a squared number again for B, so this B squared situation is positive, but now we get a negative answer. So this tells us that A is negative. When we come down to compare A and B, we know B is positive, we know A is negative, so B must always be greater than A. So we could choose here B is greater than A. Awesome.